Hello! Centrifugation is a mechanical process which involves the use of the centrifugal force to separate particles from a solution according to their size, shape, density, medium viscosity, and rotor speed. Centrifugation is carried out in machines called centrifuges. Centrifugation is used to separate the sediment from the solution and contaminated liquids. It is also used in the centrifugation of emulsion. For example, the separation of milk. Centrifugation of concrete is used to reinforce its strength. Ultracentrifuges are used to study high molecular weight compounds and biological systems. Centrifugation is used in the chemical, nuclear, food, and oil industries. Click on the centrifuge to see its structure. You can see some constituent cells in the test tube. Press the power button to start the device. So, the centrifuge begins to rotate around the vertical axis. Since the test tubes are located at an angle, the liquid in them begins to separate the constituent cells into heavier and lighter ones under the action of centrifugal forces. The resulting force presses on the bottom as denser particles sink to it. Let's schematically depict and divide the constituent cells. Let the green ones be light, red ones heavy, and blue ones medium-sized. As a result of centrifugation, these particles will have a different sediment formation rate. Red particles, being the densest of all, will sink to the bottom faster than the others. If we were to take a cell as an example, the heaviest components would be the nucleus and the mitochondria. The medium-sized ones would include the endoplasmatic reticulum and the Golgi apparatus. Ribosomes and protein threads would be on the surface as the lightest components of all. So, what is the centrifugation measured in? How to understand the concept of deeper and denser? Centrifugation is measured in such a value as the sedimentation coefficient. It is denoted by the letter S. The higher this coefficient, the denser the structure. Therefore, S will be at its maximum in the nucleus and at its minimum in the lightest components. In this way, two fractions can be distinguished in, for example, ribosomes. The first mark will be the 70S ribosome, and the second mark will be the 80S ribosome. We can understand that we have ribosomes with two different densities. Accordingly, in the centrifugation method, they are located at slightly different depths. Based on this, scientists have discovered that ribosomes can be different. Prokaryotic organisms include 70S ribosomes, i.e. those that bacteria have. Also, as the mitochondria and plastids in the eukaryotic cell were formed from bacteria, there will be 70S ribosomes in their membrane. These three structures have 70S ribosomes, whilst everyone else has 80S. These are eukaryotic cytoplasm and eukaryotic endoplasm reticulum. So, we found out that the centrifugation method depends on the speed of movement of substances through the solution as a result of the centrifugal force. The less dense the object, the closer it is to the surface, and the lower the sedimentation coefficient. And vice versa. The denser the object, the greater its coefficient and the faster it will move to the bottom of the bulb.